Hello friends. In the last video we discussed about concept of projectile motion and we said if you have a projectile motion you can solve the problem related to projectile motion very easily. One important point you have to consider is you have to decompose the motion in two dimensions, that is x direction and y direction. So what you are doing is you are simplifying a two-dimensional problem as a superposition of two one-dimensional problem. Now whatever we have learned in the previous session, we are going to illustrate using two examples in this video. So the first problem is related to acceleration in projectile motion. And this problem says, let us consider the sphere as shown in the figure below. What is her acceleration at each of the point GHI in the figure after she flies off the ramp? Neglect air resistance. So here we have a sphere and there is a ramp. This ramp is used to increase her velocity and finally she flies off the ramp and she follows a path. Now if I ask what kind of path I will have once she flies off this ramp, so at this point she is here and then she flies off the ramp. Now what kind of path you think it will have? It will have a projectile path, because at this point of time when she is just going to fly, her velocity has two components. Her velocity has x component and also her velocity has a y component, and her velocity is making an angle alpha from the horizontal. So this is the same situation but this we discussed in the previous session, that is equation of motion for projectile. So basically in this case she is going to follow a trajectory and that trajectory will be a projectile. Now we have to neglect the air resistance. So problem says you have to only consider gravity. So acceleration due to gravity you have to consider. You have to neglect the air resistance. What are the things that we have to find? You have to find acceleration at Z, H and I. So there are different points that we have. This point is Z. So this point is Z. So we have to find acceleration at this point, acceleration at this point and acceleration at this point. Now what will be the acceleration? Do we have acceleration in x direction? Since there is no force acting in the x direction, once she leaves the ramp, acceleration in the x direction is 0. What about acceleration in the y direction? Now, once she leaves the ramp, she is flying or she is moving under the gravity. So, at all the point either Z, H or I, it's a free fall acceleration. So I can say at each point direction of acceleration in the y direction, the magnitude of acceleration in the y direction is nothing but Z, and this is acting in the downward direction. So this acceleration is Z and this is acting in the downward direction. So if I assume my y-axis is upward, then I can say A by is nothing is equals to minus Z, and this is at Z, H, I. So this is very easy. Once she leaves the ramp, the acceleration in the x direction is 0 and the acceleration in the y direction is Z. When she is on the ramp, she may have different acceleration in the x direction and y direction because she is changing her speed and also the direction. So she will have both component of acceleration, but once she leaves this ramp, she is completely controlled by the gravity force. And that's why we have only one component of acceleration, that is acceleration in the downward direction, and magnitude will be Z and the direction will be in the downward direction. If I consider positive direction as the upward direction, this acceleration will be negative. Now let us discuss the second problem. So this problem is related to a object that is projected horizontally. This means alpha is 0. So from horizontal, the throwing angle, the angle by which it has been thrown is 0 degree. So this means this object is thrown horizontally. So the problem says a motorcycle, a stunt rider rides off the edge of a cliff. Just at the edge, his velocity is horizontal. So this is the motor rider, and when it just leaves the cliff, his velocity is in the horizontal direction with a magnitude of 9 meter per second. So its speed is given, that magnitude in this case is 9 meter per second. Find the motorcycle positions, distance from the edge of the cliff, and the velocity 0.5 second after it leaves the edge of the cliff. So we have to find what is the motorcycle position, that is what is x coordinate and what is y coordinate, that is position vector. And then we have to find distance from the edge of the cliff. So distance from the edge of the cliff, so this point. So this is the edge of the cliff. So what we will do is, we will consider this point as origin, that is 0, 0 coordinate. And then we have to find what is the distance, and we have to also find velocity after 0.5 second. So let us do one by one. So we have been given time, that is we have to calculate everything after 0.5 second. And the initial velocity, magnitude of initial velocity is given. So let's call u is equals to 9 meter per second. So this is given. So initial velocity u is given. Generally I use term u for the initial velocity. So this is given. Now what is my target? My target is to find this coordinate at certain point of time, that is t is equals to 0.5 second. So this will follow a parabola, because once again this is moving under gravity. So a object or a point or a particle moving under gravity follows a projectile path. So this will follow a projectile path, and let's say this is the x coordinate at time t and this is the y coordinate at time t. So we have to find x coordinate and y coordinate. So how will you calculate? Once again, acceleration in the x direction is 0 and acceleration in the y direction is equals to minus g, because my y direction is in the upward direction. Now I can use this formula or expression, s is equals to ut plus half at square, and this formula I can apply in the x direction or I can apply in the y direction. So if I apply in the x direction, I can write x is equals to u velocity in the x direction t plus half into acceleration in the x direction into t square. So this will be, in the x direction speed is 9 meter per second and the time given is 0.5 second, and the acceleration in the x direction is 0. So this term becomes simply 0. So this is, so second term is 0. So this is 4.5 meter. So x coordinate now I know, that is 4.5 meter. Now what about y coordinate? So we can apply the same expression in the y direction, that is y is equals to u by t plus half a by t square. Now in the y direction there is no velocity initially, because the total velocity is in the x direction and the magnitude is 9 meter per second. So 0 plus half, and gravity is in the downward direction, so I have to put a negative sign, and t square, t is 0.5 second whole square. Now you can plug the value of z, that is 9.8 meter per second square. So this will be minus half 9.8 meter per second square, and this divided by 0.5 second square. So if you calculate, this value will come minus 1.2 meter. So basically, what is the position? So now I know position, that is x coordinate and y coordinate. X coordinate is 4.5 meter and y coordinate is minus 1.2 meter. So negative sign here shows that the position of motorcycle is below the initial position, and that's why there is a negative sign. So now I can write position vector. Position vector is nothing but x unit vector I plus y unit vector j. So x in this case is 4.5 meter and y is 1.2 meter, and this is j cap and this is I cap. So this is my position vector. So once I know position vector, I can basically calculate the distance. So if you remember, I can source this thing here. So this is my x coordinate, this is my y coordinate, this is initial position of motorcycle, and after certain point of time, this is 4.5 meter along the x axis and 1.2 meter along the y axis. So this is the position of motorcycle, that is, this is x distance is 4.5 meter and y distance is 1.2 meter, and if you join origin and final position, that will give you the r vector. You can also calculate magnitude, that is distance from origin to the position, that is nothing but under root x coordinate square plus y coordinate square. Now I know the x distance and y distance, so I can calculate this distance 4.5 whole square plus 1.2, basically this is a negative whole square. So if you calculate this, this will come 4.7 meter. So motorcycle is at a position of 4.7 meter from the origin, and this is in the below side, downward side from the original position. Now we have to also calculate velocity at t is equals to 5.5 seconds. So let us try to calculate velocity at 0.5 second. So once again we have to use the same thing. If you remember, we have formula v is equals to u plus at. Now I will apply this formula for two direction, one for x direction, another for y direction. So if I apply for x direction, I can write vx is equals to ux plus ax times t. Now a speed in the x direction that was given in the problem, that is nothing but 9 meter per second. What is the acceleration in the x direction? There is no acceleration in the x direction, that is nothing but a speed in the x direction is 9 meter per second. You may remember this fact when we discussed the theory of parabola or projectile motion. We said velocity in x direction remains constant. This does not change with time. Now we can write equation in the y direction. We can write vy is equals to uy plus acceleration in the y direction times t. And initial velocity in the y direction is 0 and acceleration in the y direction is nothing but minus g, and time in this case is given, that is 0.5 seconds. So this will be minus 9.8 meter per second square times 0.5 second. So this will give you 4.9 meter per second. So now I know x component of velocity and I know y component of velocity. This means now I know velocity vector. Velocity vector is what? X component of velocity times I plus y component of velocity times j, and ij are the unit vector. So now I can write this is nothing but 9 meter per second times I plus 4.9 meter per second times j. Now this 4.9 is with a negative sign, so I have to put this here also. We can show the same thing in a diagram. So this is the initial position of motorbike, and at certain point of time motorbike is here. And this has two components of velocity, one along this direction, that is 9 meter per second. Another along this direction, that is nothing but 4.9 meter per second. And negative sign we already have shown by putting a negative direction of y-axis. Basically in this case my y-axis is in the upward direction, so this is towards the negative side. Resultant velocity will be in this direction. So this is the resultant velocity, and this is the x component of velocity, and this is the y component of velocity. So we can calculate magnitude of velocity, that is speed, is nothing but vx square plus vy square, and then you have to take the under root of that. So this is 9 meter per second whole square plus 4.9 meter per second whole square. And then if you take the root, this value will come 10.2 meter per second. So the object has a speed of 10.2 meter per second after 0.5 second, that is half second. We can also calculate angle. This angle, let's call this angle is alpha or alpha dash or beta, whatever you want to say. For the time being, let's call this angle is alpha. That is the resultant velocity vector. So this angle is what? The angle of resultant velocity vector from the horizontal. So we can write tan alpha. So tan alpha in this case is nothing but Vy divided by Vx. So if you see this triangle, you can basically calculate. So if you see this triangle, what is this? This is Vx, and this is what? Vy, and then this is your resultant velocity, and this angle is alpha. So if I want to write tan alpha is nothing but this divided by this, that is Vy divided by Vx. So this is minus 4.9 divided by 9. So if you calculate this and you take the inverse, or alpha is basically tan inverse or arctan, minus 4.9 divided by 9. So if you calculate this value, you will find alpha is equals to 29 degree. So motorcycle velocity is 29 degree below the horizontal. So you see in this case we calculated the velocity and we calculated the magnitude and direction of velocity. Now see in this problem, the motorbike has only horizontal speed. This does not have any vertical speed. So this means in the vertical direction, the motion is same as free fall acceleration. So you can directly calculate by or v in vertical direction if you use the concept of one-dimensional motion and free fall in the vertical direction. For example, if you want to calculate what is the y coordinate after half second, you can simply use one-dimensional free fall expression, that is nothing but minus half gt square, and this is minus half into 9.8 meter per second square, and this is in this case 0.5 second square. So you can calculate y value, which is equals to minus 1.2 meter. So the idea is, in the vertical direction, the motion is very simple. This is one-dimensional free fall because the velocity imparted to the motorcycle is only in the x direction. This does not have a bi-direction velocity. So I can simply treat motion in the vertical direction is one-dimensional free fall acceleration. So I hope you enjoyed this video, and if you like this video, please share with your friends, and I will see you in the next video. For the time being, thank you, and I will see you in the next video. Bye.